So from the last video, this is the work that shows us that indeed f and g were inverse functions. So if we were to compose them together and work out the algebra, in both cases we get x back. So this shows us that we do have inverse functions. So what we're going to do next is we're going to look at another way that we can approach finding inverse functions, and this is a more systematic algebraic approach to finding inverses of more complicated functions. And there's a nice method that we can follow to do this. So this is going to be the method we're going to use in these videos to help us find inverse functions. So what we do is we consider that we have some function of x, y, and to find its inverse, the first thing we need to do is we need to make sure that f is invertible, meaning that it needs to be a one-to-one function. If it is not one-to-one, we're going to come back to this in the next video, but this is where we have to restrict the domain to make it a one-to-one function, as we mentioned before. The next thing that we would do is we're going to go ahead and we're going to set f of x equal to y. We'll then swap the x's and the y's, so they'll interchange. Anywhere there's an x, you put a y. Anywhere there's a y, you put an x. And then this new equation will then solve for y, and the resulting function of x will be our inverse function. And then again, before we move on, we're going to want to double check that this new invertible function is also, or this new inverse function is actually invertible, and we'll check that it's one-to-one. And again, we probably won't hit this too many problems in this video, but in the next one we'll do some examples where we have to worry about that. So in this, let's just go ahead and start with an example. So let's say we're given some function f of x is equal to 1 plus 3x plus 7 divided by 5, and we're asked to find the inverse function. Well, let's go ahead and see what we can do in using this process we've outlined above. So step one, we're going to go ahead and we're going to make sure that this is a one-to-one function. Well, the good thing here is that we know by looking at this, or if we could look at it a little more closely, we see this is a linear function, so f is linear. And the fact that f is linear tells us that we have a one-to-one function. So we've discussed this before, that linear functions are going to be one-to-one. So we can go ahead and take that as for granted and move on to the next step. So in step two, what we're going to do is we're going to take this function and set it equal to y. So we'll have 1 plus 3x plus 7 divided by 5, which we then set equal to y. Alright, so the next step that we're going to do here is go ahead and swap out the x's and the y's. So here we'll have 1 plus 3y plus 7 divided by 5 is now equal to x. Now this is where sometimes it gets a little bit hairy. This one's not too bad, but in step 4 we're going to go ahead and solve this equation from step 3 for y. So we're just going to have to go through the algebra, be very careful not to make any silly mistakes, because it tends to happen with these. So the first thing we'll do is let's go ahead and subtract 1 from both sides. So we'll have 3y plus 7 divided by 5 gives us equals to x minus 1. Now the next thing we're going to need to do is we're going to need to get rid of that 5. So let's go ahead and multiply both sides by 5. And in doing that, we'll have 3y plus 7 is equal to 5 times x minus 1. So here all we did is we multiplied both sides by 5. Now we're going to resist the urge to multiply this out unless we have to, or until the end. So now we're going to have to get rid of that 7, so let's subtract 7 from both sides. So now we'll have 3y is equal to 5 times x minus 1 minus 7. And then the last thing we need to do is get rid of that 3. So we'll go ahead and we'll divide both sides by 3. And what we end up with is y is equal to 5 times x minus 1 minus 7. And then all of this is divided by 3. And this is our inverse function. So this is going to give us f inverse of x. Now what we're just going to want to do before we move on is we want to check that f inverse is linear, or is, is 1 to 1. In this case, we still have a linear function. So the fact that f inverse is linear tells us that not only is our function 1 to 1, but our inverse function is also 1 to 1, which is what we need. So now we can conclude from this process that f inverse of x is equal to 5 times x minus 1 minus 7 divided by 3. And we're done. So that was not too bad. So this was a pretty straightforward algebraically. But what I'd like to do next is an example where the algebra might get a little bit more complicated, and sometimes this will happen. So let's try this. Let's go ahead and say that given our function f of x is equal to, let's say, 7x divided by 2 minus x. Let's go ahead and do the same thing. Let's find f inverse of x. So we're going to go through the same step-by-step process that we did in the last one. So the first thing we've got to do is we've got to check to see if this is 1 to 1. Now this is a little more complicated than just being able to look at it and say this is a linear function. This is a rational function. So what we're going to do is I'm going to go ahead and bring up a grapher and let's see what we get. So I'm going to go ahead and graph our function 7x, and that's divided by 2 minus x. And you could do this on your calculator to get the same thing. And I made a typo, sorry about that. So that's 2 minus x. That'll work. So we'll go ahead and we'll graph this. And what we see is sort of a typical rational function. So we've got a vertical asymptote and a horizontal asymptote, but it doesn't look like we run into any problems in terms of it passing the vertical or the horizontal line test. It looks like we're in good shape. So we'll go ahead and we'll mark this as 1 to 1. So now if we move back, so from our grapher we've concluded, yep, that's 1 to 1. So now step 2. Step 2, we're going to go ahead and take this function and set it equal to y. So we're going to take 7x over 2 minus x, set it equal to y, and then step 3, we'll exchange these. Now we're going to want to exchange both of those x's for y's. So what we'll have is we'll have 7y divided by 2 minus y is equal to x. So make sure you exchange all of them. Now, step 4. The algebra is going to get a little bit tricky here, so follow along. We're going to want to try and isolate y. Please resist the urge to cancel those y's out, because that does not hold true for this equation. So what we're going to do, there's a couple ways we could do this, but what I'm going to do is I'm going to multiply both sides by 2 minus y here. So I'm going to take 7y over 2 minus y, and I multiply this by 2 minus y, and then I'm going to take x and multiply that by 2 minus y. So these will cancel out, and what we're left with now is 7y is equal to x times 2 minus y. Now, in order to isolate the y, what we're going to need to do is we're going to need to distribute the x over here. So I'm going to go ahead and I'm going to distribute the x. So we have 2x minus xy. And now I want to get all my y terms back over to this one side, because we'll be able to see, you maybe see this, we can factor that y out if we move that. So I'm going to add the xy term to both sides, and I'll get 7y plus xy is equal to 2 times x. Now what we can do is on the left we can factor a y out, and this is going to now allow us to solve for this, and what's left is 7 plus x, that's equal to 2x, and the last thing that we're going to have to do is just go ahead and divide both sides by 7 plus x. So what we end up with is y is equal to 2x divided by 7 plus x. And this is our inverse function, f inverse of x. So not too bad, but we had to do a little bit of trickery algebraically to get that working for us. All right, so step 5, let's go ahead and check this to make sure that this function is one-to-one. So again, I'm going to bring up the grapher, and let's see, we can go ahead and delete this. So we got y equals, and now we have 2x divided by 7 plus x, so 7 plus x. And if we graph this, we have another rational function like we expected, and this also is one-to-one. It passes the vertical and the horizontal line test, so it's a one-to-one function for sure. And we have done all we need to do to prove that this is the case, and that we've got our inverse function. So what we can conclude is f inverse of x is going to be 2x divided by 7 plus x. So that's our inverse function. Now what I want to do is I want to take this opportunity to look at some of the connections. This is our last goal, to explore the connections between inverse functions and their original functions. And what I want to do first is go bring up the graphs of these two again. So we've got one of our functions. I'm going to go ahead, I'm going to put back up our original function, which was 7x divided by 2 minus x. And I'm going to graph that on top. Now what you're going to notice here, so we've got, that's our original f of x, and then this is our f inverse. If you notice, these two functions have some interesting symmetry. Specifically, the symmetry that we see with this is that it looks like it's kind of symmetric across a diagonal. And that diagonal line can be defined as the identity function y is equal to x. So if we were to graph that, notice that if I picked any point on, let's say, my original function, 7x over 2 minus x, if I picked this point over here, there is a symmetric point directly across that line. So it looks there that we got the point 110. Well, now we've got this point over here, 10, 1. And it works for all of these points. So these two functions are symmetric across this line, and this goes for all inverse functions. So we're going to go ahead and we're going to start keeping tabs on a couple new things. So what we're going to do is we're going to notice that f and f inverse are symmetric across the line y equals x. Now this fact that y equals x for these two functions, again, we think of x as domain, y as the range. There's also another connection that we're going to see. To see this, let's consider the domain and range of each of these two functions. So let's consider the domain and range of f and f inverse here. So if we were to look at let's look at the domain of f of x in this case. Now if we go back and we look at f of x, so f of x was 7x divided by 2 minus x. This is a rational function, and if we think about this closely enough, we realize that 2 is not going to be in our domain because 2 is going to be a vertical asymptote. So we can say that x can't be equal to 2. Additionally, if we were to look at the range of f of x, so these are all the possible y values. If you remember, we looked at that graph, and also we could look at the function. This curve has a horizontal asymptote at -7 because the degrees at the top and the bottom are equal, so it's going to have a horizontal asymptote. And what we see is that y is never going to equal to -7. We could look at this by bringing up our graphs again. So this is the slightly darker one. We see that there's a horizontal asymptote here at negative 7. That's a y value that's never attained by this function. So the range is everything else other than that. If we were then to look at the domain and range of f inverse, well, for f inverse we see that we've got a denominator of 7 plus x. So in this case, x can't be equal to negative 7, or else we'd have a 0 in our denominator. And similarly, if we were looking at the range of f inverse of x, we see that it has a horizontal asymptote at 2, so y will never be equal to positive 2. And the connection that we make here is that the domain of f is going to be equal to the range of f inverse, and the range of f is going to be equal to the domain of f inverse. And this turns out to be true of all inverse functions. So aside from this symmetry, we look at this and we can conclude that this is a nice rule to keep in mind. So this is a rule for inverse functions, that if f and f inverse are in fact inverse functions, here's another two things that we're going to get. We could add this to our original definition of inverse functions. First, the graphs of f and f inverse are symmetric. Over the line y is equal to x, and then also we're going to see that the domain of f is equal to the range of f inverse, and the range of f is equal to the domain of f inverse. So this is a rule for inverse functions that we can keep in mind. Okay, so what I'd go ahead and let's try these two examples for the next one. So try these before you move on to the next video. So try these, and we're just going to go through and try and calculate using this process of finding inverse functions. We're going to try and find f inverse of x for the following two functions. Let's try f of x is equal to 2 minus 5x divided by 3 minus 1. And for a little bit of the challenge, let's try a second one. F of x is equal to 9x divided by x plus 4. And after you find these, go ahead and check to make sure that we've got this symmetry and we've got this equivalent domain and range that we've talked about in this last example. And then we'll move on to the last video after this.